three-dimensional plane. First, let us explain some problems, some concepts of plane. Then we will go for the problems. So let me explain, right? So first, basic concepts. So what is meant by the plane? Right? So suppose we have to find out the what is meant by plane, how the equations of xy plane, yz plane, zx plane, how the x-axis equation, you know all of these, you must know all the things first. So right, this suppose the plane contains, right, all of you know that. So which divide plane, so which lies the vector on the plane, or any, so suppose points lies on the plane, suppose board is the plane, this is. So in this plane, so points are like this is one vector, this is one, this is another, this one is. So board is the plane. In that one, so many, so directionless, this is one plane, this is one line, having direction ratios, this is another line, this is another line. So this is the plane about that. Suppose suppose one, this is 1, 2, 3, this is the direction ratios of one line. This is 5, minus 3, 7, this is the direction ratios of another line. So 6, 8, minus 7. This is the direction ratios of another line. Suppose they lies on the same plane, or if the so how can you find out the plane equation? How can you find out the points are given? How can you find out the plane equation? These are the very important points. Suppose plane already you know that this is the three-dimensional figure like this. So this is x-axis. You know that this is y-axis, and then this is x-axis, y-axis, and z-axis. If you take like this, z-axis. Well, observe that. So you can understand this is x-axis. Suppose this is x-axis like this. This is dimensional. This is x-axis. This is yz plane. So the plane parallel to yz plane means it is nothing but x equals to k. So the plane perpendicular to x-axis means like this. This is perpendicular to means x equal to k. So the plane perpendicular to x-axis or parallel to yz plane. This is the right. This is now we are taken as x equals to k. The same pattern. Suppose y plane is there. Suppose perpendicular to y plane, that is y-axis. A plane perpendicular to y-axis. It is nothing but y equals to, suppose y equals to some m. So the plane perpendicular to the parallel to zx plane, same like this. This is the plane parallel to zx plane, right? So remember that x equal to k is the plane perpendicular to x-axis. Perpendicular to x-axis or parallel to yz plane. Remember this. So this is the very important. How can we write? Suppose planes are there. Suppose generally, what is the plane normal form? This is nothing but normal form. What is called the normal form of plane? Normal form of plane. So normal form of plane is, suppose plane is like this. This is the normal to that. Suppose ABC are the direction ratios. Assuming this board is the plane. This plane is passing through a point Px1, y1, z1. So observe this one, board, observe this one. This is the point. This is the point. So this is the point P, x1, y1, z1. x1, y1, z1. So here ABC are the normals of the plane. This is the normal to the plane. So observe that. This is normal to the plane. Direction ratios of ABC. Then we can say that the equation, the ABC are the so drs of the normal of the plane, then we know that so that is a into x minus x1 plus y into, that is b into that is b into, we can get it as so that is so b into y minus y1 plus c into z minus z1 equals to 0. So in the normal form, that is in the vector form, r dot n cap equals to p. So where n cap is a unit vector perpendicular to the plane. This is, remember that. This is the vector form. This is the in plane, that in Cartesian form, or that is a into x minus x1 plus b into y minus y1 plus c into z minus z1 equals to 0. Where a, b, c are the drs of the normal of the plane. The plane is passing through x1, y1, z1. Understood clearly? Now, It is called normal form. What is the normal form? So this is also normal. R dot n cap equals to P. You must know the terminology. N cap is a unit vector perpendicular to the plane. N cap is a unit vector perpendicular to the plane. N cap is a unit vector perpendicular to the plane, where P is the perpendicular distance from origin to the plane. Remember that. What is R dot n cap equals to P? N cap is a unit vector perpendicular to the plane. P is the perpendicular distance from origin to the plane. So this is about the concept. R dot n cap equals to P. The plane passing through the point P x1, y1, z1. So ABC are the drs of the normal of the plane. So equation of plane is A into x minus x1 plus B into y minus y1 plus C into z minus z1. This is the equation of the plane, general form. Generally, we can take it as equation of the plane can be taken as ax plus by plus cz plus d equals to 0, where ABC are the so drs of the so normal of the plane. Remember this. This is normal of the plane. This is very important concept. So ax plus by plus cz plus d equals to 0. This is called general form of the plane, where ABC are the drs of the normal of the plane. Remember, this is the first. Suppose if you want the normal DCs of if you want, so DCs of normal of the plane, So we know that directly that is ax by root of a square plus that is drs if you want to find out, that is x not taken, that is so a by a square, that is a square plus b square plus c square, b by root of a square plus b square plus c square, c by root of a square plus b square plus c square. These are the DCs of the normal of the plane. So DCs of the normal of the plane by divided by root of a square plus b square plus c square, that gives the DCs of the normal of the plane. So ABC are where ABC are the drs of the normal of the plane. Remember that. So what is the normal form once again? So that is R dot n cap equals to P. That is terminology is most important. P is the perpendicular distance from origin to the plane. Here n cap is a unit vector perpendicular to the plane. This is a very important concept. Now all of you know that, right? Suppose a plane like this, suppose given like this, this is the plane. Suppose point 1 is like this, this is the point 1, this is the point P, right, this is P, x1, y1, z1. Suppose q, x2, right, this is q, x2, y2, z3. Suppose if you want, this is joining this one. So this is plane is like this, perpendicular to. Suppose if you want to find out the perpendicular, so plane is the perpendicular bisector of this PQ line joining. So how can I find out the PQ equation? Find out first midpoint. So find out midpoint first. So what is the midpoint? x1 plus x2 by 2, y1 plus y2 by 2, comma z1 plus z2 by 2. This is the midpoint. This point is taken as, suppose A. The plane is passing through this point. And directional ratios of PQ. So x2 minus x1, y2 minus y1, z2 minus z1 are the drs of normal of the plane. Drs of the normal of the plane. Now, we know that. How can I find out the plane equation? Point I know that directly. x2 minus x1 into midpoint. x1 plus that is into x minus, I remember that formula we are using. This is direction ratio. So taken as this is x minus point, that is x1 plus x2 by 2. Similarly, plus that is y2 minus y1 into y minus y1 plus y2 by 2. Next, plus z2 minus z1 into, that is z minus Z1 plus Z2 by 2. This is the formula we are using. So we know the drs of the normal of the plane. These are the drs of the normal of the plane. The plane passing through midpoint. This is PQ midpoint. The equation x2 minus x1 minus x minus x1 plus x2 midpoint. y2 minus y1. y minus y1 plus y2 by 2. Right, that is now z2 minus z1. z minus z1 plus z2 by 2. This is the way of solving that. So suppose concept is given like this also. Suppose plane is given like this. In this concept, from this one, suppose from here given that point is given to you. Suppose A is given A x1 y1 z1. So I put off perpendicular drawn from A to the plane. So it touches a P, right? That is. Now this put off perpendicular, right? Now how can we find out this? Suppose this is, if taken as origin is given. So P lies on our plane. So how can I find out the equation of plane? Normal I know that. So directly x minus 0 into x minus. So 0, 0 lies on the plane. Y into, so that is y1 into y minus 0. So z1 into z minus 0. That is the equation of plane. Suppose, so origin, the plane is passing through origin. So put our perpendicular given as origin from the point, we take it as like this. Suppose if it is given reverse like that. Suppose if it is given like this. Suppose point is given, that is from origin. Origin is given 0, 0, 0. So put our perpendicular is given, that is A x1 y1 z1. A x1 y1 z1. In this case, that is plane equation changes as the direction ratios x1 into x minus x1 plus y1 into y minus y1 plus z1 into z minus z1. This is the equation. This is depends upon the problem, right? Understood? Suppose from origin, put our perpendicular on the plane is x1 y1 z1, x1 y1 z1, right? So on the put our perpendicular is x1 y1 z1. This is x1 y1 z1. Then equation of plane is, so that what are the drs of normal? x1 minus 0, y1 minus 0, z1 minus 0. Formula x1 into x minus x1, y1 into y minus y1, z1 into z minus z1. This is a very important formula. Now let me explain. Suppose some problems based on this, we can easily find out that. So let me explain. Suppose all of you know that image, same concepts, straight line concepts are also applicable. Suppose from px1 y1 point px1 y1, so to the put off perpendicular to the So to the plane x plus by plus cz plus d equals to 0. So come to the formula. So that is x minus h by a equal to y minus k by b equals to z minus h k by p by, right, that is c equals to, that is minus of, substitute that, ax1 plus by1 plus cz1 plus py and root of a square plus b square plus c square. This is the put off perpendicular formula, same as straight line formula. X minus h by a equal to y minus k by b equals to z minus, that is here is given as x1 y1 z1 is from put off perpendicular. You take like this, that is here is point is given as like this, like this one is, this is here is point, this one is given, you take this point like this one is point is like this point is like this is the point, right, that is, so x minus x1, x minus x1, x minus x1, y minus y1, z minus z1, minus of ax1 plus by1 plus cz1 plus p by a square. Point is given. So this is the image, that is the put off perpendicular formula. X minus x1 by a equal to y minus y1 by b equals to z minus z1 by c equal to minus of ax1 plus by1 plus cz1 plus p by a square plus b square plus c square. If you want image concept, suppose from px1 y1, image here we take it as image again. Suppose image of right? Image of the plane is, with respect to plane is, same image. Image means we take this formula, we convert it like, that is x minus x1 by a equals to y minus y1 by b equals to z minus z1 by c equals to minus 2 into ax1 plus by1 plus cz1 plus dy a square plus b square plus c square. Same straight line concept we are using like that. So that is minus 1 into here, minus 2. This is the image concept, this is the Buddha perpendicular concept. Now, let me explain some problems based on this. We are solving a few problems about this. First problem like this. So this is the question. Drs of the normal of the plane 1, 2, 3 and distance from plane from is 5. From origin is given as 5. So now we can take the formula directly. The equation of plane is, what are the DCs of the, first we have to find out DCs. DCs of normal, DCs of the normal, right? DRs of the normal given. DCs of the normal is 1 by root of 1 square plus 2 square plus 3 square. Find out that 1 square plus 2 square plus 3 square under root. So that is how much that? 9 plus 4 root 13, right? That is, so 9 plus 1 root 14, root 14. So that is 2 by now. So 2 by root 14, 2 by root 14, now 3 by root 14. So apply the normal form, r dot, right, that is, so that is perpendicular distance form, right, r dot n cap. This is, so I, that is 1 by I by root 14 plus 2j by root 14. So now 3k by root 14. So that equals to P, 5. That is the formula once again. R dot n cap equals to P. What is n cap? N cap is a unit vector perpendicular to the plane. Now, I have to substitute that, we will get the answer easily. Now, R is nothing but xi plus yj plus zk. R is nothing but, if you take like this, R is xi plus yj plus zk. R is nothing but, if you take like this, you can take that side, I plus 2j plus 3k equals to 5 root 14. So you take the dot product, x plus 2y plus 3z gives 5 root 14. Check the answer once again. Where is that answer is? So first is the correct answer. Suppose given once again, question is given like this. Suppose the drs of the normal given, drs of the normal of the plane 1, 2, 3 is given, 1, 2, 3 given. The distance from plane is given. So we come to the formula r dot n cap. What is n cap? N cap is a unit vector perpendicular to the plane. P is distance from origin to the plane. Remember the terms. N cap is a unit vector perpendicular to the plane. P is a perpendicular distance from origin to the plane. Then apply the formula. You take the DCs. Perpendicular unit vector means is nothing but DCs of the normal. Substitute there, we will get the answer. First one is the correct answer. Now, suppose we are going to next problem, right? Now, so we will take the next question. Question is given like this. Suppose. So 2 minus 3, 6 is the foot of perpendicular drawn from origin to the plane. Then equation is asking. So question is like this. So from 2 comma minus 3 is the foot of perpendicular, right? So that is 0, 0, 0. So that is foot of perpendicular is given. This is foot of perpendicular. What is the point? 2 minus 3, 6 is given. This is foot of perpendicular. Now first find out OBDRs. OBDRs. Normal DRs. OBDRs means normal DRs. DRs are, that is again 2 minus 0, minus 3 minus 0, that is plus 6. Now, we take the red formula. Normal DRs, we know that. Equation. That I plane crossing through that. So that is 2 into x minus x1. X minus 2 plus minus 3 into y minus 3. The minus or minus plus 3. Plus 6 into y minus 6 equals to 0. Minus 36. We check the answer, we will get the answer easily, right? So that is, it is nothing but, suppose minus 49. 4, that is minus 40. So that is minus 40 minus 9, minus 49. This one is the correct answer. So come to this one again. So is the foot of perpendicular from origin. So like that. This is OBDRs, we know that. OBDRs. So 2 minus 3, 6. We know that. 2 minus 0, minus 3 minus 0, 6 minus 0. This is the DRs of the OB line. The plane passing through this point, x1, y1, z1. Apply the formula. X of x minus x1 minus, so that is DRs a into x minus x1, b into y minus y1, c into z minus z1 equals to 0. Then that gives the equation. So fourth is the correct answer. So let me explain another formula, another problem. Right, this is a plane passing through whose normal makes equal angles with the coordinate axis. Here is the problem. Already point we know that given x1, y1, z1 is the point given. This is the point given, and the coordinate axis, it is nothing but remember that equal inclined means direction ratios must be 1 comma 1 comma 1. So directional cosines, so equal inclined, remember that plus or minus 1 by root 3 plus or minus 1 by root 3 plus or minus 1 by root 3. This is the directional cosines. These are the DRs, equal inclined to coordinate axis. Then direct substitute that a into a is nothing but 1 into x plus 1 minus or minus, apply the formula a into x minus x1 plus b into y minus y1 plus c into z minus z1 gives 0. So apply that formula. So 1 into x plus 1 next 1 into y minus 2, 1 into z minus 3 gives simplification, right? X plus y plus z, 1 minus 2 minus 1 minus 1 minus 3 minus 1 minus 1 minus 3 minus 4. Check the answer, which is the correct option. This is the correct option. So once again I will explain this question, right? So here is that is given like this. So my z minus that is 3. So if simplification 1 into x, 1 into y, 1 into z. 1 minus 2 minus 1 minus 1 minus 3 minus 4. So once again, so here the plane passing through and whose normals are equal inclined. Whose normal means normals DRs must be normal DRs must be DRs. These are the normal DRs 1 1 1 because equal inclined to the coordinate axis. So that is the basic concept of this. Now let me explain the next question. Now let me explain the next question. Question number is 4, right? This one is given the equation of perpendicular bisector of plane line joining. Perpendicular bisector, he says that perpendicular bisector already told that. So find out the midpoint. So equation of plane passing through the point and parallel to the line. So parallel to the lines means this normal DRs is same as that. So same 2 1 1. 2 1 1 1 is also required DRs of the plane. So normal of the plane, that is 2 because parallel 2 1 1 are the DRs of our required plane. Remember that because plane is parallel to this plane. So equation of plane, already DRs normal we know that. The equation of plane, apply the formula a into x minus x1 plus b into y minus y1 plus c into z minus z1 equals to 0. The plane passing through the point, DRs I know that. Substitute that is 2 into x minus plus 2 plus now 3 into now this is plus 3 into y plus 1 plus now plus c. C is nothing but 1 into, right, that is 1 into 2 1 1 2 1 1. This is also 1. Take like this. This is also 1. So 1. So plus 1 into z plus 3. That is given. Right. If you simplify that, we will get the answer correctly. So that is 2x plus now y plus z to 4, that is 4 plus 1 plus 3, that gives 8. Check that, 2x plus y plus z plus 8. So this one is the correct answer. So the equation of plane passing through that and parallel to the plane means so 2 1 1 DRs of the, so the DRs of the normal of plane, required equation, that is apply the formula A into x minus x1, B into y minus y1, C into z minus z1. The plane is passing through this point and normal d is given as 2, 1, 1. Apply the formula. 2, 1, 1. A into x minus x1, B into y minus y1, C into z minus z1 gives the correct answer. Now, let me explain another question. Now, you are taking this question, write this. Right, the equation of plane passing through the point and parallel to zx plane. So I told you that parallel to zx plane. Already I told you that zx plane, if you take like this, zx plane. Suppose if given plane direction like this, this is so this is x-axis. So this is x-axis. This is y-axis. So this is z-axis. So parallel to like that, this one means perpendicular to x-axis. Perpendicular to x-axis means it is nothing but x minus k equal to 0. Remember that. So the plane is parallel to, the plane is plane parallel to, so given as zx plane. Now zx plane means it is perpendicular to what? So zx plane. So right, it is, remember that, right? This is parallel to, right? This is given as zx plane means plane is perpendicular, right? Right. Plane is perpendicular to. So zx plane means y-axis. Perpendicular to y-axis means y minus k equal to 0. Y minus k equal to 0. Passing through this point, substitute there. Y minus, it is nothing but what is y? You have to take that. So right, that is, so y minus 3, substitute there. Minus 3 minus k equal to 0. So minus 3 equal to k, substitute that, you will get the answer. So that is, so substitute here, right? That is k is minus of minus 3, y plus 3 equal to 0. That gives the second is the correct answer. Remember that. So plane parallel to zx plane means plane is perpendicular to y-axis. This is very important concept. So plane is perpendicular to y-axis means equation is y minus k. It is passing through the point 2 minus 3 5. Substitute there. We will get straight away. We will get the answer. This is if the plane is perpendicular to xy plane, z minus k equal to 0. Xy z minus k equal to 0. The plane is perpendicular to z-axis. Here is plane is parallel to zx plane. Zx plane is parallel to y-axis. Simple concept. Now let me explain the another question. Now this is the question, right? So the equation of perpendicular bisecting line joining segments, right? The equation of perpendicular bisecting of plane line joining the segments minus 3, 2, 3, 2 and 9, 5, 4. This is the given. So these 2 points are given like this. Previously we are discussing this model. So plane one point is here, another point is here. Midpoint lies on this plane. And it is perpendicular to it. So A is given, B is given, and midpoint lies on it. A is given as first point. So that is minus 3, 3, 2. Now B is given as 9, 5, 4. So midpoint, that is midpoint. Minus 3 plus 9, 6 by 2, 3. So 3 plus 5 by 2, 4. Now, so 6 by 2, 3. This is point, midpoint. So find out the DRs. 9 minus 3. So DRs of AB line. So that is AB line. 9 minus of minus plus 3. Right. 5 minus 3. This is the 5 minus 3. And 4 minus 2. 4 minus 2 are the DRs of AB line. Now, so this is 12. This is 2. So we cancel it 1. DRs of AB line. 6, 1, 1. DRs of AB line. AB line means normal of the plane. So then equation we know that A into 6 into point we know that x minus 3. Right, that is. So right, that is. So you can take it like this. right? That is x minus point is 3. 1 into y minus 4 plus 1 into z minus 3. We can find out that. That equals to 0. So find out that 6x plus y plus z minus 18 minus 4. So minus 18, this is minus 4, minus 22, minus 3. So minus 25, this is the correct answer. You go through simplification, 6x plus y plus z, that is minus 18, minus 4, minus 22, minus 3, minus 25. Take that side, we will get it as 25. This is the correct option. So midpoint we have to find out. So AB midpoint we have to find out. So minus 3 plus 9 by 2, 3 plus 5 by 2, 2 plus 4 by 2. So midpoint lies on the plane and ABDRs. ABDRs are nothing but the normal DRs. We have to find out the equation. Now let me explain the another question. Now let me explain another question. So right, this is the question. The distance from to the plane is k, is 3. Then find out k value. So already you know the distance formula. Simple question is mod of x1 plus dy1 plus cz1 plus dy under root of a square plus b square plus c square. That is given as distance is 3. Then find out the k value. That is substitute there, apply the formula. The distance from 1, 2 into 1, that is 2 into 1. Now plus 3 plus 2 into y 2. Now minus z minus 4. So that is minus 4 plus k by under root of a square. It is nothing but 2 square plus 2 square minus 1 square. That gives given as 5. So find out the k value. We will get it easily. This is 3. So the 2, that simplification. 2 plus 4 and this is minus 4 plus k, minus 4 plus k, modulus is there, equals to how much? This is 5 into 3. So that is nothing but perpendicular distance, 3, 15. So if you take the modulus, we will take that. So 4 cancel. So 2 plus k equal to plus or minus 5. So k plus 2 equal to 5. So k plus 2 equal to minus 5. Check that which one is the correct answer. K equal to 3 or k equal to minus 7. Either this one or this one. So which one is important? That is k equal to 3. 3 or that is s1 equal to, that is 2, take that side, minus 7. So this is the correct answer. So 3 is the correct answer. So once again. So application, that is point, that is given 1, 2 into 1, that is 2 into 1, 4, 2 into 2, 4, minus 4, plus ky, root of a square, 2 square, 2 square, minus 1 square, equal to 5. This is 3, 15, right? That is, right, 4k, 2 plus k equal to 15, there is no mistake, 2 plus k. So that is 2 plus k equals to 15. 2 plus k equal to 15, if you take like that, 15. So that is k plus 2 equal to 15. So k equals to 13. 13 is not there. 13 is not there, right? So that is k plus 2 equal to minus 5. If you take like this, that is 15. So that is minus 15. It is given as minus, it is nothing but k plus 2 equals to k equals to minus 17. Either 13 or minus 17. It's not there. So you take that sum. So that one is, so this is 13. That is 13 is, this is the correct answer. That is, so that is the correct answer. That is 3 is minus, this is not there, right? That is 13 is the correct answer. So formula, apply the formula. Mod of ax1 plus by1 plus cz1 plus d by root of a square plus b square plus c square gives distance 3. So that is simplification. 2 plus k equals to, so that is plus or minus 15. That is, take that one, we will get the answer. Now let me explain another question. Right, that is the distance between parallel lines, parallel planes given. Remember that. Suppose ax plus by plus cz plus d1. This is one plane. Again same, ax plus by plus cz plus d2. Then they are said to be parallel planes. Parallel distance between parallel planes. Distance between parallel planes. Parallel planes. It is nothing but remember the formula, mod of d2 minus d1 by root of a square plus b square plus c square. This is about the formula of distance between parallel planes. So you take that one. Here is 4 is there, here 2 is there. This is multiplied by 2. So then what we are getting? First plane 4x. So that is 2y. So this is 4z. So multiply every term equals to, that is minus 8 is minus 16, 0. Now 4x plus 2y plus 4z, that is plus 5, equals to 0. So find out that the distance between the parallel planes, that is the given formula. Apply the formula, minus 16 minus 5 mod of pi root of a square. So that is simplification, 16 plus 4 plus 16. We will get it as like this. This is nothing but 21 by, that is 6. So 3, 7 by, so 3 the 2 times cancel, that is 7 by 2. Third is the correct answer. First we make it as like this. First understand the concept. These are the planes. These are the parallel planes. The distance between parallel planes formula, d2 minus d1 by root of a square plus b square plus c square. This is the formula we are using. So that is distance between the parallel planes, you are taking that mod of. So d2 minus d1 by root of a square plus b square plus c square. We'll get it as 7 by 2. Third is the correct answer. Now let me explain another question. Now this is the question. This question is also completed. This question is also completed. Now this one. So the ratio in which the plane divides the line segment joining, this is the point. These 2 points are given. So right, this one apply the formula. The ratio is nothing but minus of ax1 plus by1 plus cz1 plus dy. Remember the formula. That is ax2 plus by2 plus cz2 plus d. This is the formula. First remember that. So the 2 points joining these 2 points divides. This is, if it is totally positive, this is greater than 0, means the point internally. If it is negative with this one sign, so they are externally. Let us explain that, discuss this one. Apply the formula there. That is, so what is the formula using that? What is the plane given? So 2x plus 3y, right? So 2x plus 3y, apply the formula there, right? That is minus of. So 2 into minus 1, 2 into minus 1. Now 3. So what is the plane equation given? Once you see that 2x plus 3y, right? That is, so 2x plus 3y, 3 into 2. Now next, minus 2 into z3, that is, right, that is z3. Now next, it is plus 7 by simplification. This is very important. Now that is, again this point substitute that, 2 into 2 plus 3 into 3 into 3. Now 5 into minus 2 into 5 plus 7. Simplifying, we are getting the answer. That is minus of. This one is minus 2 plus 6 minus 6 plus 7 by 4 plus 9 minus 10 plus 7. This is minus 6 cancel. So right, that is 4, 9 minus 10. This is minus 10. And simplification, that is 7 minus 2. Minus 2 means minus of 5 by, here if you take like this. So right, that is 4 plus 9, 13. So 13 plus 7, 20 minus 10. So that is, it is nothing but minus 1 is to 2. Minus means 1:2 externally. So this is the correct answer. So all of you know, first try to understand the concept and solve the problems where easily you get to solve the problems. Right. All of you know this one. How to do the formula first? So the line joining means you can go through the formula once again. This one. This is given as the problem. The ratio in which the plane divides the line segment. So x1, y1, z1, x2, y2, z2. Plane is given ax plus by plus cz plus d is given. Minus of ax1 plus by1 plus cz1 plus dy. ax2 plus by2 plus cz2 plus d. That gives the answer. Right? So in this session we are going through problems, all different model problems. So listen, go through the formulas first, then concepts first, then you go through the problem, easy to solve it. So next video we will discuss about the other concepts, right? So thank you for listening my video.